Let's have a look at modern equipment which has been kindly brought with Orange County Radio Society. Now we're going to see a practical example of these propagating waves, and Mr. Kinetic has come over from Orange County Radio Society with his equipment to show us how the theoretical work can actually be used in practice, and you'll see the differences. Would you tell us what the equipment is, please?
This piece of equipment that I brought is going to serve as the generator of the RF energy for our day. So it will be transmitting. It's actually a fairly sophisticated piece of equipment that has 3 transmitters and 3 receivers. The lowest frequency for this transmitter is 144 megahertz, which is about 2 meters of propagation wavelength. In addition to that, there's a second transmitter that is 440 megahertz, and then finally there's another transmitter that is 1200 megahertz, or 1.2 gigahertz. Now, each one of the transmitters has its own transmission line coming out and going to a apparatus here that's called a triplexer. So it's connecting the output of 3 different RF generators, combining them into a single connector for cable that will go to the antenna. Now, this antenna here is designed to be about 1 meter long. We'll be pumping electrical energy into this antenna and then using it to propagate into both the electrical field as well as the magnetic field. The transmitting antenna has a couple leads on it that are connected to the oscilloscope. So we'll be watching the electrical voltage that's being applied to the antenna on the oscilloscope, and we'll be able to see the envelope of that voltage.
See this in action then?
Testing. This is W6 Hotel Canada.
Well, now we'll go over and look at the receiver and see how that operates in conjunction with the emission of these radio waves at this end.
What we have is an antenna that is going to be used to pick up the electromagnetic field. It's going to couple into the receiver here using a piece of coaxial cable. For the demonstration, we have set up the oscilloscope leads to pick up part of the energy that's being coupled into the antenna. So the signal comes in on the antenna, goes through the coaxial cable into the receiving circuits, and the receiving circuits will demodulate the signal that's been received at 144 megahertz, separate out the audio portion of that signal into a speaker. So let's have a demonstration. Could you go ahead and key up the transmitter?
CQ. This is W6ZE calling stateside.
This is the received signal. This is the voltage on the receiving antenna.
Well, one more measurement, and I'd like to ask the question, what am I holding in my hand? Looks very interesting. Can you see it? It's a coil. So how do you think this figures into it? The single conductor received an induced voltage in response to the electric field, and a coil, according to Faraday's law, will respond by developing an EMF in response to the changing magnetic field. Let's see if there is one. Ken, give us a voice over your transmission link, and we'll see if a voice comes out of this speaker. We can't show it you on the scope because the signal's smaller. It's going straight into the amplifier. But as Ken explained, we can rectify the RF wave, if there is one, and hear the impressed voice. I wonder if there's one there. Give us a signal.
Testing. This is W6HHC. Testing. 1, 2, 3, 4.
Well, that's a relief. You did see that it was just as clear. We were getting a signal now from the magnetic component. Now you have living proof that electromagnetic waves do indeed consist of an electric wave and a magnetic wave, and they go through space together. I'll see you in the next tutorial.